So in this lesson we're going to be learning about interior and exterior angles of polygons. First of all, we're going to understand what is a polygon. So a polygon is a 2D shape that is made up of straight lines. So it can't have any curves, it has to be straight lines. They are flat and closed and look something like this. So here we've got a triangle, we've got a quadrilateral, and we have a hexagon, a six-sided shape. Now here's just a quick image of what a regular polygon looks like versus what an irregular polygon looks like. They're all polygons because they are all 2D shapes composed of straight lines. However, a regular polygon is one that is equal in all dimensions. So its angles are equal, its sides are equal, everything is equal. An irregular polygon still has the same amount of sides, therefore it's still called a triangle, quadrilateral, pentagon, if it has 5 sides and things like that. However, the only difference is it's irregular, and the reason for that is because its lines are not the same length and its angles are also different. But as long as they have the same amount of sides, they can be given the same name, just irregular version of that regular polygon. So what I like you to do is to pause this video and copy out this table, and we're going to fill it out as we go along in this video. So let's start off. Our first column, we've got number of sides. So an equilateral triangle. This one's quite an easy one. So equilateral triangle has 3 sides. A square has 4 sides. A pentagon has 5 sides. A hexagon 6 sides. Heptagon 7. An octagon 8. A nonagon 9. And a decagon 10. Now, the number of side n-side polygon, that's the only one that's going to be slightly different. And the reason for it is because we actually don't know what the number of sides is. So a number of sides is going to be determined by n. Okay, so n is the number of sides, and we're going to use that in order to find polygons where we're not given the number of sides. So next thing is size of exterior angles. So the formula for a size of exterior angles of a regular polygon is 360 divided by n, and n is the number of sides of the polygon. So if we have a look, our equilateral triangle has 3 sides, therefore it's going to be 360 divided by 3. Our square has 4 sides, so 360 divided by 4. Our pentagon, 360 divided by 5, 360 divided by 6 for our hexagon, and it just keeps going. And obviously, using your calculator, calculate what each one of these equals. Octagon 360 divided by 8, a nonagon is 360 divided by 9, a decagon is 360 divided by 10, and then our n-sided polygon is 360 divided by the number of sides, and our number of sides is n, because we actually don't know it at the moment. And then all you have to do is just find the answers to these. Obviously this one's not going to have an answer, but all the others will. This one just stays as a formula of 360 divided by n. And it should look something like that. Our next column is sum of interior angles. So the formula of sum of interior angles of a polygon is number of sides take away 2 times by 180. And obviously n is represented as the number of sides of the polygon. So for our first one, we've got sum of all interior angles for our equilateral triangle. So we're going to have 3 take away 2 multiplied by 180 equals, for our square, same thing, 4 take away 2 multiplied by 180 is equal to, our pentagon, same thing, 5 take away 2 multiplied by 180. We've got 6 take away 2 multiplied by 180. 7 take away 2 multiplied by 180 for our heptagon. 8 take away 2 times by 180 for our octagon, 9 take away 2 for our nonagon, and 10 take away 2 for our decagon. Obviously all of these are times by 180. And then our n-side polygon, so a polygon where we actually don't know the number of sides. So number of sides is n take away 2 multiplied by 180. So that just goes back to the actual formula that we're given at the start. But if you're not given the number of sides, that's the formula that you'd obviously use. So hopefully yours will look something like this with all of your answers when you've found the answers for your sum of interior angles. Finally, size of one interior angle is sum of interior angles divided by n. So sum of interior angles is the answer that you got in the previous column. So 180, 360, 540, 720, and so on, divided by the number of sides. So for our equilateral triangle, our sum of interior angles is 180, divided by number of sides is 3. Our square is 360, divided by number of sides is 4. Our pentagon is 540, divided by 5. 720, divided by 6. 900, divided by 7. 1080 divided by 8, 1260 divided by 9, and 1440 divided by 10. For our n-sided polygon, it's going to be n take away 2 times by 180, and all of this divided by n. Because our top part is our sum of interior angles, which is this one here, and then sum of interior angles divided by number of sides, we're not told, so it stays as n, so that will be our formula. So once you have found the answers, it should look something like that. And have a look at this. These are the final answers for all of our full table. Here it's missing equilateral triangle, and that's supposed to mention square. But that's our answers. So make sure that your table is filled in completely. Now I'd like to pause this video and have a go at these questions. All the questions give you little hints on how to start them, but have a go at these. And the answers to the following are: now, an interior angle of a polygon are on the inside, we already know that, and therefore our exterior angles are on the outside. And you'll notice that our interior and exterior angles, when they're joined together, they're actually on a straight line. And we should know that angles on a straight line add up to 180. So sometimes in a question, if it asks you to find the exterior angle and it gives you that interior angle, all you actually have to do is do 180 subtracted by whichever angle they've given you. So if they give you an interior, you take away the interior to find the exterior, and if it's the exterior, you take away the exterior to find the interior. But remember, they're on straight lines, therefore 180 take away whatever you're given gives you the opposite angle on that line. This is just a quick note in case you might need it in future questions. So this is going to be, I'm going to go through the first question of each of these, and then I'm going to ask you to pause the video and have a go at the other two questions. So you'll see that these are irregular polygons. The reason for it is because they are not equal in size or in length or in angles. They're all irregular, but they are still polygons. They're 2D shapes that are connected with straight lines only. So for the first one, if we count the number of sides, we have 5 sides. And we're trying to calculate that unknown, so A. At the moment, we're trying to calculate this unknown angle. So it has 5 sides, so the sum of angles is 5 take away 2 multiplied by 180 gives me 540. So the formulas that we've got can work for irregular polygons. So some of the angles for our 5-sided shape, we use our formula n take away 2 times by 180. Our number of sides is 5, so 5 take away 2 times by 180 gives me 540. I then know 4 of my interior angles. So we know that all of our 5 angles added together are going to give me 540. So I can add 160, 50, 140 and 90 and subtract it from 540, giving me an answer of 100 degrees. So what I've done here is I have added these 4 angles together, and they have given me 420. I then have done 540 subtract 420, which is giving me a value of 100 degrees for A. So I know A is equal to 100 degrees. So what I'd like to do is pause this video and have a go at B and C. Right, let's go through the answers. So for B, it's a 6-sided shape. So our sum of angles is 6 take away 2 multiplied by 180, which gives me 720. What we know is that all of our angles added together are obviously going to be 720. When I add the 5 angles that are already given to me, I get 570. I then obviously do 720, subtract 570, giving me B having a size angle of 150 degrees. For C, this is a 5-sided shape, okay, so it's a pentagon. So it would be 5 take away 2 multiplied by 180, giving me 540. I know that I've got 4 of my angles, 30, 45 and 2 90-degree angles. When added together, give me 255. Subtracted from my sum of 540, I get C having a value of 285 degrees. So exterior angles, they're just straight lines coming off of your shape. And they always, you'll notice, this is another quick note to add to your notes, is that all of your exterior angles, when you add them together, they will equal 360 degrees. So let's have a go. So I'm going to go through question A and then pause the video and have a go at B and C. So for A, our exterior angles, we know that exterior angles add up to 360 degrees, always. Okay, so for A, we are given that one angle is 100 and 2 angles are 90 degrees, because hopefully you should identify that when you have that little square in one of your angles, it means that it's equal to 90 degrees. So when we add our 3 given angles, we get 280 degrees. We then subtract it from 360, giving A a value of 80 degrees. So pause this video and have a go at B and C. Remember, all exterior angles added together equal 360, so it's quite a simple one to do. Let's go for the answer. So for B, we know the exterior angles add up to 360. We are given 135, 55 and 60. When adding those 3 together, we get 250. Subtracted from 360, we know that B has a value of 110. And for C, again, all of our exterior angles are up to 360. We are given our 58, our 83, our 72 and 95 degree angles. Added together, we get 308. And then we subtract the answer from 360, which gives us a value of 52 degrees for C.